Hello students, welcome to Arush coaching classes, and we will be learning about another technique of tree traversal today.
Depth first search. Okay, so by the name itself it says which travels vertically, which travels along the y-axis, which travels vertically. Okay, so that is what is depth, and that is why it is called depth first search. Okay, now let us begin. In the last class we've learnt about BFS, that was breadth first search. Here it is depth first search. So how do we go about it? So let me just start off. So I will say, okay, this is a tree which I have taken over here. Now what will I do? I'll quickly make this for all of you. This is F and this is G. Okay, so in the last class we learnt about that it works on the principle of Q, right? That is FIFO. But depth first search works on the principle of stack, that is LIFO. LIFO means last in, first out. Okay, now how do we go about it? See, in the stack, see if this is a stack, stack means this, like this. And here when you put something inside, alright, it is called push. Okay, and when you bring something outside, it is called pop. Okay, so this is the principle over here. So I can write also for you, this is outside. So push and pop. So obviously if you observe carefully, suppose here it is A, B, C and D is the last thing. So whatever you put in, now you cannot move from here, right? You have to come out from this place only. So if this is push, then this only will come out, that is pop, right? So this is the basics of stack. Okay, you can also see my video which I will be uploading very soon. Alright, so the principle of stack is clear, and on the same principle now we will travel along the what do you say this? Along the tree. So let us begin. So first obviously we start with the root. So let me put here DFS sequence. So first is A. Now from A you can go either here or you can go here. Any way you can go. So how we will go? We will make a stack, and from A you can either go like this, B and C, or you can go like this, C and B. Both the ways are correct. Okay, but in the last class I have taken the approach from left to right. So today I am taking the approach for this one. Alright, so what I will do is I will remove this one and I will start off with this. Okay, now see, so A, now what will happen? After A you are moving to C. Now what I have to do, if I have to move further here, I will have to remove C, correct? So this I will pop out, right? Because this was the one which I have popped in. So now this will go out. So the second is C, and once the C is out, C will go to what? C, G and F. So this is the first step. The second step will be C. B will remain as it is. We will not touch anything over here. Correct? What we will do? We will write F and then we will write G. Okay. Now why have I written F first and G second? Because we are following the sequence like this. So I am taking it this way. Okay. You can also write the other way. But since you are following the same sequence, I would request to go along the same path. Right? Now this is what it is. Now after G, see how it is traveling? It is traveling along. Right? It is like depth. Or you can say the deepest node. Okay? There are no other items. Otherwise it will keep on going down, down, down. Right? So that is what it is. Okay. So now what I will do is I will go to the next step. What I will do, I will remove G from here. Now since G is gone, now below this nothing is there, so it will backtrack now. So once your nodes are finished, it starts backtracking. And what do you mean by backtrack? It goes to its parent one, correct? So after A, C, what will come here? G. Now this will go to C again. C, we have already done the work. Now after C, where it will go? It will go to A again. So definitely we don't have to worry about it. Now after this, it will go to B, correct? Now how do we go about it? See here, no, when you are going from G, correct, you are left with what? The third step will be B and F, right? G we have already removed. Now when you have to go from here, I have to see, I have reached this B, but I have to reach here also. So what will I do? I will remove now F, correct? So it will be A, C, G, F. Now the fourth step, now we are left with what? Now we are left with what? That is B. Why? Because F we have already removed. Now B will go. Now once we reach this B, it will take us to D and E, correct? So see, A, C, F, and after F we will take B. And then when you are removing B, what are we left with? The fifth step will be D and E, correct? Okay. Now what will happen? We will first, see, this is the last step. So first we will remove E and then we will remove D, correct? So this is the sequence for DFS. Alright, this is called depth first search. Okay, so one thing you are clear that it works on the stack principle. It goes to the deepest node. There we were going the shallowest node, right? It is called the blind search because you don't know where, till where you have to go, till where you have to reach. Alright, plus this is also incomplete, correct? And that one is called optimal. This one is called non-optimal. Why do we call non-optimal? Because you don't know, right, till where it is. See, the point we are trying to say is, suppose the tree is very big, very big. Suppose we are traveling, down, 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 down. We'll keep on traveling. So what will happen in that case? Maybe these are the few things which are left behind, correct? So we don't want all this to happen, correct? So that is why it is called incomplete. Okay, so you just have to remember in DFS that first step you go like this, go down, then second step go down. Once the nodes are finished, go backtracking, like go to your parent again. Okay, once you've reached your parent, then again the next node, then again the next node, so on and so on. Okay, so I think this is clear, and that was about depth first search. I hope you've liked this. Please like, subscribe and share the channel. Thank you.